can see here material is getting deposited. The UV light is shown as green color here. You can see how like a paste it is dispensing, and it is then exposed to UV light. So that's how the part is built. You can see here some of these technologies, when compared to the powder bed, they're very fast. You can see the multi-jet fusion of HP and powder bed fusion. You know, in fiber bed fusion, in the powder bed fusion, you have the laser making kilometers it has to run, whereas on the right hand side you have things which are done instantaneously. So that's what is required for production, right? And so the world is moving, catching up with the speed that is required. So this is yet another technology called directed energy deposition. We can use metal parts in this. Even in fact, gold can also be 3D printed. We have a sample. We have a tie-up with the Cookson Gold. Okay, the US and Cookson UK, they have a collaboration, and Vaseline is also a collaborator, a partner with that, and we have a platform which is built with pure gold. So even that is coming. So with that, the gold loss will come to 1%, which is a record minimum that you can think of. But of course, there are other issues. How to make that powder the powder making is very costly. You know. So for example, this is my ring. I'll say, okay, I'll get it, whatever, you know, today's price, 6,000, 8,000, 10,000, I don't know. But if I make it by 3D printing, by this route, I'll have to pay something like 60 to 70,000. Can you believe it? So it is not viable right now, but technologies are going to become viable very soon. Once upon a time, when diamonds were all lab grown, they were supposed to be very expensive. Many people thought, no, at this rate, we cannot produce it. We just have proved that diamond can be made in lab, and that's it. Today, what is the status? Diamonds can be made in lab, cheaper, much cheaper than the natural diamonds. And it is a great challenge, right? On one side, it's an opportunity. On the other side, it's a great challenge, because people are not ready to pay for diamonds much. So the whole diamond this thing collapsed. And but people are now again going back, to tell a story how a natural diamond is made. It goes into the earth crust, remains there for millions of years due to enormous energy, heat and pressure. It takes the form of a pure form of carbon. Okay, all the stories bolna padte hai abhi. Then there is an inclusion, but whatever you grow in lab is always flawless, pure, element kind of thing. You can do it. So people are looking for some kind of natural formation, the characteristics of a natural formation, to value diamonds in future. So same thing is going to happen for metal also. Today it is costly. Tomorrow maybe diamond can be set in a 3D printer, and people are even thinking of 3D printing diamonds. Can you imagine? Anything, any fancy shape. You design a shape and you get it by 3D printing. But not now, but it is all in R&D. You'll get one. You can see here how a thin layer of metal powder is getting sintered. It is easier to melt a powder, at a lower temperature than an actual metal. Can you imagine? A powder, in fact, metal powder, aluminum powder are used in crackers. How they use in crackers and all. If you open, you will see a silver-like material. It is with gunpowder and other so many material. They'll also have metal powder in that. Okay, and so they'll give the sparkles, what you see. And so metal powder, they melt at a lower temperature, and so that is a very important. That's why we need to use a metal powder, and that metal powder is very costly. The making of metal powder is very costly. can see a different method wherein the powder is directly melted at the tip using laser, and various technologies are coming there also. And you can see some of these are big printers, metal printers. You can print a big chassis of a car, a rocket, something. Even there, what you see, mostly they're all like a box, no? Even that will change. You can see a robot now. It doesn't look like a box. Can you imagine this is a 3D printer? By definition, it is taking CAD data and it is depositing layer by layer clay, okay? And so you can repeat it, not only in one place, but all over, all around it. It can, a truly out of the box 3D printer, you know what you call. And so people have been looking at various things. Some of these are like a glue gun or mehendi lagate hai na, I say. One can use it in hand and try to do the, it is like FDM, filament deposition, correct, no? You can, especially jewelry designers, you're all very skilled. You can try to do something, right? But you need to do it by hand. Is it 3D printing? Is it 3D printing? No. It is not 3D printing because there is no digital input data. There is no digital input data, number one. And is it making it layer by layer? It is not making it by layer by layer. Okay. More than that, digital input data, supposing this is put on a robot and robot is getting digital input data, then this becomes a 3D printer. Got my point, no? As it is handheld, it is not a 3D printer. Though it is looking like, working like a 3D printer, whatever you have in your mind, it comes to hand and you are then depositing. And let us see how it works. You know, it is as easy as this. One can make this like a craft. No layer by layer, and you're not firing from the computer, right? There is no digital input data. So this is not a 3D printer. See this one, is it a 3D printer? You don't have to only 3D print down, it can also be on the side. So these are some of the stereotype, it is questioning stereotype. It can also print in space, for example, where there is no gravity. You know, such mechanisms help. So what is additive but not 3D printing? Laddu. Laddu is made of so many bundis, no? They are put together, additive. You make a ball out of it. So it is additive? Yes, additive. But is it 3D printing? No, it is not 3D printing. But it is additive. Same way, what else you can think of? You can think of the sandwich. What you see here is additive, right? Layer by layer is there. There is no digital input data. You know, so it is not 3D printing. Well, Dr. Adrian and his team, they started a new concept, 3D printer printing itself, replication of a rapid prototype project. So what you get is a 3D printer printing itself. A cartoon was made just to make a fun of the whole concept. But it is true, in HP, multi-jet fusion printer, 50% of the parts are used in the mission or done by the same technology. Can you imagine? No, it's very important. You can see they come in all shapes and sizes. These are some of the things what you may see. And today, this technology is making deep inroads in every possible sector. Jewelry, medical, FMCG packaging, lifestyle, architecture, automotive, aerospace, electrical electronics, white goods, plastics, and many more. Okay. So what is the beauty of this technology? This brings things which are impossible to think. You know? Impossible to think. These are all not created by sketching. They are not done by CAD. They are done by programming, computer programming, right? You substitute n is equal to 1, n is equal to 2, n is equal to 3. Okay, 3 gives you me a good shape. Okay, export it as STL file. Like that, you know. So it is becoming a digital kaleidoscope. Digital kaleidoscope where you don't even know what you are going to get, but you substitute a number and get a configuration, and then you finalize that as an object, export it as STL, and then send it to 3D printer. 3D printer prints it. These are impossible objects, unimaginable objects also, because it is difficult to imagine such objects, right?